when we were supposed to be using it. So again, we'll have some more practice here. So if no diagram is given, which would that be? Draw one to represent the situation before completing the problem. So draw a picture. Express all lengths to the nearest tenth and all angles to the nearest degree, and make sure you have units. That's the number one thing. You'll lose a half mark. Okay, so when you're doing these, the first thing you should always check for is right angles, because then you would be using the basic trig ratios. See, so if it's not a 90-degree triangle, a right triangle, check the triangle for a side and a opposite angle. Remember, the sine law is you have the known pair, right? If you have a known pair, then you use the sine law. If none of the above possibility exists, use the cosine law. Does everybody agree that the sine law was easier than the cosine law? Yeah, and that basic trig ratios was easier than the sine law, or about the same? Yeah, so this is kind of a progressive difficulty. Okay, so let's see. In the following triangle, solve for side C. Where's side C? Opposite angle C? So, is this a right triangle? Nope. Is this something we can use the sine law with? Oh yeah, it is. There's a known pair. What's the known pair?
I see a known pair.
Oh, there's a known pair there. It might be a known pair in disguise. So how would we figure out what this angle is right now? 180 subtract 125. And what do we get? 55? So sometimes your known pair is in disguise. But we know that the angles of a triangle add up to 180 degrees. So if I want to find side C, what form of sine law would I use? Sine C over C or C over sine C? Yes, C over sine. Now we're not going to write sine C. We're going to write sine 75 degrees equals, and I'm trying to find a known pair here. So this is going to be 38 over sine of 55 degrees. So do a cross multiply, and who can tell me what C equals?
Make sure you can use your calculator.
Yes, so when you do a cross multiply, you will get 44.8 centimeters. Okay, example 2, we're trying to find angle B. Okay, so I heard cosine law. Why would this be cosine law? We know 3 sides. So side, side, side automatically is going to be, unless it's Pythagorean theorem, like the right angle.
Eliminate that there's no right angle before you solve.
And so you can't assume because something's drawn to look like a right angle, it is a right angle. You never assume that, okay? So you have to use mathematical proof that there's a 90-degree angle in here. There isn't. So side, side, side automatically is the cosine law. So here is what we're trying to find, B. So we're going to, now, on the formula that we're going to be using, the form of, so that it's cos, technically it's a B, but you can use cos A, but we'll just write cos B. So what does cos B equal? A squared plus C squared minus B squared divided by A times C. Okay, so let's plug her in. Cos B equals A squared is going to be 49 squared plus C squared is 39 squared. Does everybody know where I'm getting this from? 57 squared divided by 2 times 49 times 39. Does everybody see in the formula that those numbers end up being that? Yeah? That's like a nice check, right? Okay, so I'm going to get my calculator. You can get your calculator too. You should be able to do this in one fell swoop. So I would do brackets 39 squared plus 49 squared subtract 57 squared bracket divided by bracket 2 times 39 times 49 bracket, get an answer. And that answer better be between what two numbers for cos? -1 and 1. And then last step, we have to inverse cos the answer, right? The previous answer. So we get, what is that? 80. I'm just going to make this smaller. Whoops. So, therefore, B is approximately 80 degrees. Okay, so this is not even word problems at this point. This is just a review of what you learned over the last 2 lessons, right? Okay, so we're good? Now we'll do some word problems. Okay, so a tower is supported by 2 guy wires attached to the top of a tower and fixed to the ground on the opposite sides of a tower, 27 meters apart. One wire is 19.3 meters long and meets the ground at an angle of 53 degrees. So let's draw a picture of what that looks like. Okay, so I'm going to have a tower here. Here's my tower. And we have a wire coming down and a wire, say, coming down like that. And here's the ground. Right? And what else do I know? 27 meters apart. The 2 guy wires are 27 meters apart. And one wire is 19 meters long, 19.3 meters long and meets the ground at an angle of 53. So I'm going to make this one the 19.3 meters, and then this is the 53. Does everybody see that? So, does everybody have a diagram similar to that? Yeah? I guess the only mistake you might make is you make the tower too big, and then you don't realize this is going to be a big triangle at the end, right? So, how would we figure out the height of the tower? Remember, this is my tower here. How would I figure that out? What's the first thing you're supposed to check for? Is it a right triangle? Oh yeah, there's 2 triangles there. There's 2 right triangles there. A tower would automatically be perpendicular with the ground, right? So this is just a matter of right angle trig. Yes, unless it's the Leaning Tower of Pisa. Okay, so let's call this, say, x. So what would this be? SOHCAHTOA? Sine, cosine, or tangent? Which one? How can you do Pythagorean theorem? Who says this is in half? Well, how do you know it's in half? It's not.
In half if both the wires are the same length.
You're making stuff up now. The only thing you know is this is at 90 degrees because a building would be perpendicular with the ground. This is 53 and this is 19.3. You don't need to. You guys, you're not looking at this triangle right here. This is just sine. Sine of 53 degrees is equal to opposite x over hypotenuse 19.3. X is approximately 15.41, so 15.4 meters. That's the height of the building. The second wire is this right here. Does everybody see? Now we have a big triangle here. We know this side. We don't know this side, but we have this angle. Can anybody tell me what law or what thing am I going to use? Can I use? It's going to be a cosine law. So let's call this y. Why? Because I used x already, and I'm not going to use it again because I already have x in the question, right? Or do you want to use it as a? It doesn't really matter, and then I guess we're using the formula for cosine law. Sure, we'll use little a. We can use y, it doesn't matter. They're all variables. So a squared equals b squared. Maybe we should label what these all are, right?
No,
if this is little a, this is big A. This is B, say, and this is C. So this is little c and this is little b. Yes? Back in the day when you're doing right angled trig, what was the first thing you always labeled? The hypotenuse, and then you went the opposite and the adjacent, right? So a squared, that's what we're trying to find. A squared equals b squared, so 27 squared, plus c squared, which is 19.3 squared, minus 2 times 27 times 19.3 cos of 53 degrees. We get our answer, then we square root it, right? I'll give you a second to figure it out. Sorry, 27 squared plus 19.3 squared, subtract 2 times 27 times 19.3 cos of 53. So then I get an answer, and last step, I square root the previous answer, and I get 21.8. Okay. I don't have room for this, but I'll put it right here. I'll put it right here. Okay, so my answer is approximately 21.8 meters. Okay, what angle does the second wire make with the ground? How would I figure that out? You could use the sine law at this point. What else could you use? Well, there's a bunch of different things you could do, but in the end, like, all you need to do is find this angle, right? So what do you want to do? You want to use A? I would use the previous answer and not round again, because you're going to be off otherwise, right? You could also use the sine law. Honestly, I think the sine law gives you a better, well...
Use the sine law and use A in the previous.
Yeah. Yeah.
You got to use the previous answer.
You have to use the previous answer. So I could, because I know this tower, I'm actually using a rounded amount for this, and I'm going to be using a rounded amount for this. So your answer is going to be a little bit off if you use 2 rounded answers. I would try to just stay with 1 rounded answer, and that would be the sine law. So sine of C over 19.3 equals sine of 53 degrees over 21.8, but I'm going to use the 21.8 as a previous answer in a calculator. Does everybody see that? So I'm not really rounding yet. I have it in my calculator. So cross multiply that over. So I'm going to go 19.3 times sine of 53, close my brackets, divided by my previous answer. And I get 0.70777, and then last step I have to inverse sine my answer. So look how nice my angle ends up being there, 45. Did you guys get that? Okay, I'll give you a second. Okay, so I'll just write my answer here. So C equals 45 degrees. Okay, next one, example 4. To determine the height of a cliff, a surveyor measures the angle of elevation of the top of the cliff from a point away from the base to be 45 degrees. He then moved 20 meters further away from the base of the cliff and found the angle of elevation to the top to be 37 degrees. Determine the height of the cliff. So last year in grade 10, you learned what angle of elevation was. And what is that? Horizon, looking up. What's the other way? Depression. Eye level, looking down, right? Okay, draw a picture. Okay, we have a cliff and the ground. Does everybody have a cliff and the ground? You could say the cliff is like right here. Okay, and some guy's right here, and he measures a point from the base 45 degrees. So this is 45 degrees. Then he moves 20 meters further away from the base, and he measures it to be 37 degrees now. So from here to here is 20 meters. Does everybody see? Okay, so determine the height of the cliff. So how are we going to do this? You would use the sine law first, but the problem is it's highly in disguise what you're actually doing here, right? So the first thing somewhere you learned, if an angle hugs a line, you should be able to figure out what that angle is right there, because they're a linear pair. And it's what? 135. Does everybody see that would be 135? Which means then you can figure out that small angle way up there. And what would that be? I'm sorry? It's 8 degrees. So now I have a known pair. Does everybody see? Now I have a known pair. So what I'm going to do right now is I have a known pair with the 8 and the 20, and I need to know this because then I can do right angle trig afterwards to find the cliff height. So I'll give you a moment if you want to continue. Okay, so I'm going to go x over sine of 135 equals 20 over sine 135 sine of 8. So I do a little cross multiply action and I get sine of 135 times, I can't see what I'm typing, 20 divided by sine of 8. $101.6. Is that correct? Okay. Is that what you got, Brandon? For the first one? 101.6? I'm finding x here. So that would be meters. So now I'm going to, does everybody see? I'm going to use the sine law to find, because this is the opposite and this is the hypotenuse, but I'm going to use my calculator so I don't round twice. Yeah, for this one.
Yeah.
Okay, so sine of 37 degrees is equal to opposite, which is y, over my previous answer, 101.6. Do a cross multiply. Y is going to be sine 37, close my brackets, times my previous answer, and I get 61.2 when you round it.